Hi folks, now this is our last division rule, constrained equal losses rule. Well here, equality, we keep talking about equality, but what are we equalizing? So previously we were trying to equalize what the players can get, whether it is the half of the claim or not. But here we are trying to equalize how much loss players are going to suffer, or in terms of how much of their claims they're not going to be able to get. So that is sort of the loss, and so we are trying to equalize that. So formally, I think formal definition is easier to understand. For any division rule, CE, and for any agent I, what we have is the following. I denoted, by the way, a constrained equal loss rule by CEL. CEL of player I, the reward for player I under this claims problem, is the maximum of these two terms, 0 or CI minus lambda, whichever is the maximum, where lambda is chosen such that when we sum the reward vector, well, we get exactly E, meaning the rule basically satisfies efficiency. All right, so the lambda is chosen for efficiency. Well, here lambda is the loss. All right, so everybody is going to lose some part of their claim. I'm sorry, we cannot give everybody what they claim. So we are going to subtract something from everybody's claim, and that loss is equal for everyone. Okay? Well, obviously, if some creditors or some agents have very large claim and some others have very small, and then lambda is very big, well, this CI minus lambda could be negative for those players, agents who have already small claims. So what we do, we just give those guys 0. I mean, we can't give them negative, obviously, because that is the assumption. And so we give them 0, but for everybody else, for those who have big claims, we subtract the same amount of loss. Okay? Well, I have a numerical example. I keep doing the same example just so that you can compare the different outcomes. Well, here is the surplus is 200. There are 4 agents with those claims. So how do we find lambda in this problem? Well, simple. Well, first of all, what is going to be the constrained equal loss rule reward vector? All right. Well, it is going to be, for first player, maximum of 0 and his claim 100 minus lambda. Remember, lambda is fixed for every agent. For second agent, it's going to be maximum of 0, 0 minus lambda. And for agent 3, the maximum of 0, comma 200 minus lambda. So 0, 200 minus lambda. And then finally for agent 4, it's going to be max of 0 and 100 minus lambda. Okay? So once again, let's have a look at it first. Well, is max of 0 and 0 minus lambda. Well, again, lambda is going to be a positive parameter. It will never be negative. And so the max of this term is always going to be 0. Good. Well, what about those guys? Well, here, depends on what the value of lambda is, right? So here I compare 100 minus lambda with 0 and 200 minus lambda with 0. So therefore, I need to look at, several cases. One, lambda is less than or equal to 100. While lambda is maybe higher than 100, but less than or equal to 200. And then lambda is greater than it doesn't matter where you put equality, okay? I put equality here. Lambda is greater than 200. So let's look at the last case. Lambda is greater than 200. So if lambda is way too high, well, what happens? This guy is negative. This guy is negative. This guy is negative. So everybody's going to get 0. But then we're not going to satisfy this. So we can't have I mean, I put contradiction sign, but we can't have lambda in this range. Well, what about this case where lambda, I mean, I don't know why I'm doing the first rather than second, I don't know. Can I find a lambda less than or equal to 100? Well, let's see. If lambda is less than or equal to 100, well, this is going to be positive. So the max of this is basically 100 minus lambda plus, well, this guy is 0, so I ignore that. Well, this one is 200 minus lambda. It's also positive. So therefore, the max of it is 200 minus lambda. And finally, 100 minus lambda. So this has to be equal to E, which is 200, remember? Is there any lambda which solves this equality? Well, 100, 200, 300, 400 minus 3 lambda equals 200, which basically means 200 divided by 3 is the lambda. Well, which is like, again, 66.66 or 67. Is this less than or equal to 100? Yes. So you know what? I found lambda in this range, which specifically this value. Well, now you can check if you like this case. You're not going to be able to find anything, but let's check. If lambda is greater than 100, so this is negative, so this is 0. This is 0. What about this guy? Well, this guy is 200 minus lambda, right? Because lambda is less than or equal to 200. So this is 200 minus lambda. And this is 0. So this has to be equal to 200. Well, that means lambda is equal to 0. But remember, to begin with, I assumed lambda is higher than 100. So I can't have any solution in this case either. So that means in this problem, the constraint equal loss is going to distribute the surplus in such a way that it will take 200 divided by 3 units away from each player. If it is for this guy, obviously, it's just going to give him 0. All right? So what does that mean? That means the reward, CEL, for this specific problem is going to be 100 minus 200 divided by 3. Okay, well, the max of this and 0 is this, and so I ignore the max terms. Here it is 0 for the second guy. The third guy, it's going to be 200 minus 200 divided by 3, the lambda. And then finally 100 minus 200 divided by 3. So if you just do all this, subtraction, I have 100 divided by 3, 0. This is 600, 400 divided by 3, and then, the same thing, 100 divided by 3. And as you add them up, as you will see, it's going to be equal to E, 200. Okay, so this is how the reward vector will be for the constraint equal loss rule for this problem. All right, well, if you change the claim vector or the surplus, obviously everything will change, but I think you got the sort of the mechanics of this problem. Well, now let's look at the properties. It clearly is efficient, right? Because by definition it satisfies efficiency and hence feasibility. While the non-negativity is again coming from the max of 0 and this term. So this term is negative or positive, who cares? Therefore, this term will never be less than 0. So it's non-negative, obviously. Claim boundedness, well, here I have the maximum of this thing can be CI if lambda is 0, okay? And so therefore, claim boundedness. Well, equal treatment of equals, obvious. Lambda is same throughout through all the players, agents. And if CI equal to CJ, obviously their rewards will be the same. I keep saying obvious, but you should probably give yourself a few minutes to convince yourself that you don't really need to write down a long proof for all those claims.